Welcome to the day 6, guys. Today we will complete our BFS and DFS that we have been solving for past 3 days. And after that, I have planned to move forward to the shortest path finding algorithms like Dishkastra, Floyd-Warshall, Bellman-Ford. And then we will move forward to the other topics of the graphs. So without wasting any time, let's get started with today's video. The first problem that we are going to deal with today is find closest node to the given two nodes. You are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. The graph is represented with a given zero index array edges of size n, indicating that there is a directed edge between from node I to node edge I. Okay. If there is no outgoing edge from I, then edge I is equal to minus 1. Okay. You are also given two integers node 1 and node 2. Return the index of the node that can be reached from both node 1 and node 2 such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return minus 1. Note that edges may contain cycles. Okay, so what we are given is a graph that is mentioned already, and the graph is represented using a zero indexed array edges. Okay, zero indexed array edges of size n, indicating that there is a directed edge from node I to node edge I. Okay, so at index 0, it is mentioned there that it is 2. So from 0, there is an edge to 2. At 1, there is mentioned 2. So at index 1, there is 2. So there is edge from 1 to 2. At index 2, there is mentioned 3. So there is an edge from 2 to 3. And since at index 3, it is minus 1, then there is no edge. Okay, great. So this is a graph representation. Okay. You are also given two integers node 1 and node 2. We are given two nodes node 1 and node 2. Return the index of the node that can be reached from both node 1 and node 2 such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. If there are multiple answers, return the node with the smallest index. And if no possible answer, return minus 1. Okay. So the distance, let's just work with the first example. We have this graph, and what is the answer of this particular? We have to find the distance from node 0 and node 1. Okay, the distance from node 0 to node 2 is 1, and the distance from node 1 to node 2 is 1. The maximum of those two distances is 1. It can be proven that we cannot get a node with a smaller maximum distance than 1. So we return node 2. Okay. So we have to find a node such that its distance is minimum from both the nodes. From node 2, the distance for node 1 and node 0 is minimized in both cases. Let's see, in this particular case, node 1 is 0 and node 2 is 2. Okay, then what is the node that can be reached with the minimum distance? That is node 2. Because from 0 we can only reach node 2, and node 2 can't go any further, so it will only reach itself. The distance from node 0 to node 2 is 2, and the distance from node 2 to itself is 0. The maximum of those two distances 2. It can be proven that we cannot get a node with a smaller maximum distance than 2, so we return node 2. ओके ग्रेट। तो हम लोग को करना क्या है, दो नोड दिए गए हम लोग को, और हम लोग को एक ऐसा नोड फाइंड आउट करना है जिससे उन दोनों नोड की डिस्टेंस मिनिमम हो। अब ज़रूरी नहीं है कि ये मिनिमम डिस्टेंस दोनों तरफ से इक्वल हो। इट इज़ नॉट फिक्स दैट द डिस्टेंस शुड बी इक्वल फ्रॉम बोथ साइड। एक तरफ से मैक्सिमम डिस्टेंस ज़्यादा भी मिनिमम डिस्टेंस ज़्यादा भी आ सकती है और दूसरी तरफ से कम, लेकिन जो डिस्टेंस है ना वो ओवरऑल बाकी सारे नोड से कम होनी चाहिए। ओके, तो इस क्वेश्चन को हम अपने वाइट बोर्ड में ले चलते हैं और पहले एक ग्राफ बनाते हैं। You have this node and then this edge, continuously drawing every day and my drawing is getting better. 1 2 0 एंड 3। ओके, सो अब देखते हैं कि हम मिनिमम डिस्टेंस कैसे फाइंड आउट कर सकते हैं। वैसे तो मैंने अपने पिछले वीडियो में आपको बताया था कि मिनिमम डिस्टेंस फाइंड आउट करने के जब क्वेश्चन आते हैं तो हम लोग BFS प्रेफर करते हैं DFS से। अब हम DFS भी लगा सकते हैं इस क्वेश्चन पे, लेकिन देखते हैं इस क्वेश्चन को हम BFS से कैसे करते हैं। तो हम लोग को नोड 1 से BFS स्टार्ट करनी है और फाइंड आउट करना है कि हम कौन से नोड पे पहुंच सकते हैं और उस नोड पे पहुंचने के लिए हमें कितनी डिस्टेंस लगेगी। तो जैसे मैंने कहा था, BFS लेवल बाय लेवल ट्रैवल्स करती है। लेवल बाय लेवल ग्राफ भी आपको समझना पड़ेगा। लेवल बाय लेवल ग्राफ है, हमेशा ऐसा लेवल लगता नहीं है, लेकिन हाँ, फॉर बेटर अंडरस्टैंडिंग ऐसे समझ सकते हैं। देखिए, नोड 1 है, नोड 2 में जाने के लिए कितनी डिस्टेंस लगेगी 1। ये हमारा कौन सा लेवल हो गया, फर्स्ट लेवल। ओके, from node 2 we can go to node 3। for this particular thing the next level is node 3। तो ये कौन सा लेवल हो गया, सेकेंड लेवल। तो हमारे क्यू में हमने इनकी डिस्टेंस पुश कर, तो हमने पहले इनिशियली 1 पुश करा रखा था अपने क्यू में, यहाँ पे इसकी डिस्टेंस 0 थी। उसके बाद 2 पुश हुआ मेरे क्यू में, डिस्टेंस 1, एंड देन 3 विद डिस्टेंस 2। तो इसके लिए एक सेपरेट वेक्टर मेंटेन कर लूँगा, डिस्टेंस वेक्टर, और जैसे जैसे लेवल बढ़ता जाएगा मैं उन सारे नोड को लेवल वैल्यू असाइन करता जाऊंगा। ओके, ग्रेट। नाउ सिमिलर फॉर दिस नोड 0 ऑल्सो। मैं यहाँ से नोड 0 से एक BFS कॉल करूँगा और अगले नोड पे जाऊँगा, फिर उसके बाद एक BFS और कॉल करूँगा, फिर अगले नोड पे जाऊँगा। सो दिस पर्टिकुलर क्वेश्चन आई थिंक इट्स प्रिटी ईजी इफ़ यू हैव वॉच्ड माई प्रीवियस वीडियो, क्योंकि इसमें सिंपल सा BFS का कॉन्सेप्ट लग रहा है जिसमें हमें मिनिमम डिस्टेंस निकालनी है और बस जो मिनिमम डिस्टेंस हम लोग की बेस्ट आ रही है उसी को इंडेक्स को रिटर्न कर देना है। ओके, तो पहले एक सिंपल BFS लिख लेते हैं जो कि होगी, अगर तो BFS लिखने से पहले इसको एक ग्राफ में कन्वर्ट करें कि ना करें, क्योंकि जैसे देखिए इसमें एज है तो हर नोड से एक ही एज जा रहे हैं, तो हम लोग को ग्राफ में कन्वर्ट करने की ज़रूरत नहीं है। हम लोग सीधे डायरेक्ट एज उठा सकते हैं, वरना एक अनऑर्डर मैप में ग्राफ बना सकते हैं हम लोग। दैट्स नॉट अ बिग डील, लेकिन स्टार्ट करते हैं। सो हम लोग को वेक्टर चाहिए होंगे डिस्टेंस के लिए। सो आई हैव अ वेक्टर इंट डिस्टेंस 1, वेक्टर इंट डिस्टेंस 2। इसको नेम दे देते हैं फॉर डिस्टेंस फ्रॉम नोड 1 for distance from node 2। ग्रेट। अब हम लोग के पास दो डिस्टेंस आ रहे हैं जिसमें हम लोग अपना आंसर स्टोर करेंगे, राइट। आंसर हम इसमें स्टोर करेंगे तो मुझे BFS कॉल करनी पड़ेगी, राइट। चलिए BFS कॉल कर लेते हैं। फिर BFS में इनिशियली क्या जाएगा मेरा, नोड 1, तो मैं नोड 1 को भेज दूंगा। डिस्टेंस वेक्टर जाएगा, डिस्टेंस 1 मेरा चला गया। क्या क्यू यहाँ से प्री बिल्ड करके भेजें कि अपने आप रहेगा? अच्छा, विजिटेड वेक्टर की ज़रूरत पड़ेगी। विजिटेड वेक्टर की ज़रूरत, विजिटेड भी हम वहीं पे बना लेंगे, राइट। तो फिर हमें ज़रूरत किस चीज़ की है, बस एजेस की बची है, क्योंकि एजेस भी तो पास करने पड़ेंगे हमें, क्योंकि हम अनऑर्डर्ड मैप तो बना नहीं रहे। तो सिर्फ एजेस की ज़रूरत बची है। डिस्टेंस 2 and then pass edges again। okay, now what will happen is these find the distance of every node from node 1 will find the distance of every node from node 2, right. These two are basic BFS call that we will be making here। okay, great। अब BFS कॉल के लिए हम BFS भी लिख लेते हैं कि हमारा BFS जाएगा कैसा है। सो हम लोग को BFS में रिटर्न क्या करना है, हम लोग को डिस्टेंस रिटर्न करनी है, लेकिन वो तो मैं डायरेक्ट वेक्टर से अपडेट कर दूंगा। तो लेट्स क्रिएट अ वाइड काइंड ऑफ BFS, वाइड BFS int node vector int, let's call it distance only, and then what we'll be passing is what we are passing is edges, right? Vector int edges. Okay, now what I need to do is create a queue, queue, that we have int, call it queue. Now what I will do is queue dot push my node. After pushing my node, what I need to do is one thing more. I need to create a new start. Start is equal to 0. This will help in my level order traversal from one level to next level, from one level to next level. Okay. Now one thing more that is required is a vector pool called visited. Okay. This will be visited array. Okay, visited का size कितना होगा? visited का size जितने नोड्स हैं हम लोग के पास एजेस में उतना ही हमारा साइज होगा। तो ऐसा करते हैं, ग्लोबल बना लेते हैं इंट n, और यहाँ से एजेस का साइज निकालेंगे टू साइज, राइट। तो यहाँ पे जो हो n false, each of this is marked as false. Now what I need to do is call it a simple BFS. Why not q dot empty? Okay, int size is equal to q dot size. Great. Now what I need to do is while size minus minus, we need in top, you can say just this particular case q dot front and then q dot pop. Okay, whatever the level is, just push that level. So what will be the level here? What will be the level here? We have distance, right? तो लेवल भेजने के बजाय अगर मैं डिस्टेंस ही वो कर दूं इस तरीके से, जैसे डिस्टेंस मेरा नोड है मेरे पास, डिस्टेंस नोड 0, जो नोड है उसको मैंने 0 कर दिया। अब क्या होगा, जैसे मैंने क्यू से पॉप करा, मैं एडजेसेंट नोड पे जाऊंगा। एडजेसेंट नोड क्या होंगे? इंट ई इज इक्वल टू एच इज ऑफ टॉप। ओके, डिस्टेंस में जो टॉप है ना, वो कुछ नहीं होगा, वो होगा डिस्टेंस टॉप की नहीं, सॉरी ई की, डिस्टेंस ऑफ टॉप प्लस 1। मैं अपनी डिस्टेंस अपडेट कर दूंगा। ओके ग्रेट, और इसको क्यू में भी पुश करना पड़ेगा, क्यू डॉट पुश ई। ओके, क्यू में भी ई पुश हो गया, और do I need to do anything else? I don't think so. यहाँ पे इनिशियलाइज नहीं, इसको इनिशियलाइज करते हैं सही से। n कॉमा माई डिस्टेंस कितनी है हमें मिनिमम फाइंड आउट करनी है ना, तो इंट मैक्स, और सेम ही यहाँ पे भी करेंगे, कॉमा इंट मैक्स, राइट। अपार्ट फ्रॉम दिस, अब मैंने BFS करके हर नोड की, इस नोड से नोड 1 से हर नोड की डिस्टेंस फाइंड आउट कर ली, और हर नोड की नोड 2 से डिस्टेंस फाइंड आउट कर ली है, राइट। अब एक एग्जाम्पल केस लेते हैं। सा इम्पोर्टेंट केस है इसलिए okay, so let's create this node. We have this and then we have this. Okay, okay, then we have node 1 as here, 2 here है, 3 ये 0 है और ये नोड है मेरी नोड 5 फॉर नाउ। अब नोड 1 की जो डिस्टेंस नोड 2 से है वो है 1 और नोड 0 की जो डिस्टेंस है नोड 2 से वो है 2। इस केस में हम लोग इस केस को इन दो नोड को कंसीडर कर रहे हैं टेस्टिंग के लिए। अब जो डिस्टेंस है बेस्ट आंसर ये नोड 2 है हमारा। अब ये बेस्ट आंसर क्यों है ये चेक कर लेते हैं। पहले हमने अपने 1 से एरे बना लेते हैं और ये 1 एरे है और मैं एक और एरे बनाऊंगा 0 एरे, इसमें 0 से डिस्टेंस स्टोर होगी। ओके, 1 की 0 से तक की कितनी डिस्टेंस है इनफाइनाइट, क्योंकि हम 1 से 0 नहीं पहुंच सकते। ग्रेट, 1 से 1 जाने की डिस्टेंस 0 है। ग्रेट, 1 से 2 जाने की डिस्टेंस 1 है। 1 से 3 जाने की डिस्टेंस इनफाइनाइट है। 1 से 5 जाने की डिस्टेंस भी इनफाइनाइट है। ओके ग्रेट, अब 0 से चेक करते हैं। 0 से 0 जाने की डिस्टेंस 0, 0 से 1 जाने की डिस्टेंस इनफाइनाइट, कांट बी रीच्ड। ओके, 0 से 2 जाने की डिस्टेंस 2। ओके, 0 से 3 जाने की डिस्टेंस 1। ग्रेट, 0 से 5 जाने की डिस्टेंस इनफाइनाइट, कांट बी रीच्ड। ओके, नाउ हमें 0 और 1 से मिनिमम डिस्टेंस फाइंड आउट करनी थी। इंडेक्स यहाँ से स्टार्ट करी। फर्स्ट कंपैरिजन नोड 0, 0 पे 0 की डिस्टेंस 0 लेकिन 1 पहुँचने की इनफाइनाइट, तो इनफाइनाइट है, आंसर बहुत बड़ा है। अब नोड 1 पे आए तो नोड 1 की नोड 1 से पहुँचने की डिस्टेंस 1 है लेकिन नोड 0 से 1 पहुँच नहीं सकते, तो अभी भी आंसर इनफाइनाइट। नोड 1 से और नोड 1 से 2 पहुँचने की डिस्टेंस 1 है और नोड 0 से 2 पहुँचने की डिस्टेंस 2। अब इसमें से जो डिस्टेंस है वो बेस्ट आंसर होगी मैक्सिमम ऑफ दिस 2, तो 2, क्योंकि दोनों में से मैक्सिमम निकाल के हम अपने पास स्टोर करेंगे। तो अब मेरा आंसर अपडेट हो गया 2 पे, क्योंकि हम यहाँ पे मिनिमम लेंगे, मिनिमम ऑफ प्रीवियस कॉमा करंट डिस्टेंस। ओके, तो अब मेरा करंट डिस्टेंस कितना अपडेट हो गया 2। नाउ मूविंग फॉरवर्ड, यहाँ पे डिस्टेंस कितनी है इनफाइनाइट और यहाँ पे कितनी है 1, तो फिर अगेन इनफाइनाइट आ जाएगा हमारे पास आंसर, क्योंकि रीचेबल नहीं है। तो वी वॉन्ट अपडेट हियर बोथ आर इनफाइनाइट, तो हमारा बेस्ट आंसर कौन सा आया, मिनिमम डिस्टेंस 2। ये किस पे आई थी, इस नोड पे आई थी, तो हमने ये नोड उस समय स्टोर करा लेंगे अपने पास। सो दिस इज अ सिंपल लूप दैट वी विल बी running on both of the arrays. Okay, now what I need to do is run this. So first thing first, int min, what shall I name it, min this node is equal to -1, क्योंकि कोई एरे में नहीं मिला है आंसर तो ये हो जाएगा। और min min till now, that would be int max, I would say, much better. Now for int I is equal to 0, I is less than n plus plus min till now is equal to आई थिंक फर्स्ट हमें एक मैक्सिमम स्टोर करा लेना चाहिए। इंट मैक्सी वुड बी मैक्स ऑफ डिस्टेंस 1, सॉरी डिस्टेंस was vector comma distance in the second vector for that particular node, and then min till now would be minimum of तो एक कंडीशन में से डालना पड़ेगा ना, इसको एक कंडीशन में डालना पड़ेगा कि इफ min till now is greater than maxi, then do one thing, that is update min till now is equal to maxi first thing, and then min dist node would be ith index, right? Then do nothing, then just return min dist node, right? Right, I guess like to me this shall work. Let's try to run this. If there is no compilation error or spelling error, then it shall work. Okay, there is in node 2. And what is the issue in my BFS? It shall be node 2. Great. And is there any issue further? Let's try to run this. See if there's any error. Got runtime error. Why? Addition of unsigned offset overflow. कहाँ पे दिक्कत आ रही है? Addition of unsigned offset. Addition 3 हो रहा है. Ages is equal to 2 2 3 1. ओके, तो हम लोगों ने एक केस ने हैंडल करा है कि अगर हम लोग की एज एग्जिस्ट नहीं कर रही यानी -1 है पेरेंट, तो वो वाला केस, और वेस्टेड भी नहीं चेक करा तो हम लोग लूप में भी फंस सकते हैं. दो इशू तो ये हो गए. तो यार वेस्टेड हम लोग ने मार्क नहीं करा नोट 1 नोट 0 को. पहली गलत चीज़ तो यहाँ है कि हमने विजिटेड नहीं मार्क करा. विजिटेड node is equal to true. Great. First thing first. Now what I need to do is, if e is not equal to -1 and not, okay, visited of e is equal to false. If it is so, then do this. Distance of e is equal to distance of the, what node it was, top node plus 1, and q dot push e, right? Right. Great thing. Okay, what I need to do is, have I written it well? Yes, I've written it well now. I guess shall work this time. Okay, again getting unsigned line number 98. Unsigned long, what the vector end BFS distance edges is dot size q q dot push node. Great. Distance of node, right? Visited node, true. Just getting started and the first answer does not even work. I hate runtime errors. I have BFS start with a Q, then I push my node. Distance is 0. Create a bool vector that is visited and mark the node as visited. Great. While not q dot empty, size equal to q dot size minus minus, and top is equal to q dot front, q dot pop. T is equal to edges top. Okay, great. Mhm. Yes. Now, if e is not equal to minus 1 and visited e is equal to false, then distance of e is equal to distance of top, and it works well so far. Then we have edges size. Great. We have distance 1 and distance 2. Distance 1 and distance 2 are passed. Max is equal to max of distance 1 I comma distance 2 I, and min till now is greater than max e, then min till now will become max e, and the answer is in my and return in this node. I guess I am doing pretty right. Then what is the issue that is causing this run timer? Don't wanna use GPT to find it. Hmm, what is the issue? Okay, I have a node. Not returning anything. Mm-hmm. Oh, sure. Distance is not equal to minus 1. Distance is. Okay, front. This is meeting distance. Create two vectors called the BFS on these two particular nodes, and then. And then is equal to h dot size. Great. Runtime error. Store to null pointer of type bit type. Guess we have to go to GPT to find what the hell I am doing wrong here. Let's go to GPT and see what is wrong with this. Why runtime error? Hmm. So what? Okay, this was working. Yes. Sometimes just keep in the code. Okay, it's giving TLE now. We are getting a TLE. Time limit exceeds in BFS. Hmm, it's a great show. So yeah, having this sort of in loop. This is good. Then this is this Q part. Simple BFS. It shall. Okay, there's this Q another, and then there's this side of Q. Since I'm not doing it level by level, why not just remove this Q part? If I remove this Q part, what will be happening? Let's see. There should be some auto formatter. Okay, it's not formatting. Let's see. Whether it works. Let's try to submit this now. Okay, still the TLE persists. Okay, great. Uh, Getting a TLE. Mm-hmm. Okay, boy, getting a TLE is another great thing that has to encounter. Now, how can I optimize this if there's a TLE in this particular portion? I think it should have worked, but I guess it is not. Hmm. What is the number of nodes? You can do a 5. But getting a TLE is not something that I was expecting for this particular problem because it's a simple BFS problem. How can I optimize it further? I have a queue. I push my node distance of node is 0 and is false marked as true while not QMT. Not front is size is not required. Remove this. Just say you have this particular part, right? It's not needed. Let's just retype. In top is equal to q dot front. Okay, great. Now what I do is q dot pop. Okay, now let's call it d is equal to edges of the top, right? And if yeah, sorry, e is not equal to -1 and not have been visited so far. Visited so far. E. Great. Then do one thing, that is update the distance. What the distance of E is would be distance of the top plus 1. Great. And then q dot push E. Great. And I have removed that while loop part. I shall be working retained with state loop true. Distance of start node was 0, right? And now it shall work, I guess. Why this has come down here, I don't know. Vector and images. Okay. Let's try to run this. Again a TLE, and I don't know why I'm getting a TLE now. I don't know why I'm getting a TLE. How am I supposed to optimize a simple BFS further? TLE. I'm getting a TLE. Fine. Sometimes. And max size or the max but notice. I'm getting a TL in this particular thing. It's a cheap D. Why I'm getting TLE. I'm missing updating BFS inside the loop. Okay, so I'm not visiting it. Okay. Make visited is equal to true. Let's see if this time it works. Okay, it has passed. Great. The first problem takes the longest. Okay. Making a large island. This is the next problem that we have to deal and work on it. Great. Hmm. A hard problem. Let's see what it is all about. Let's just first clear this particular thing. Making a large island. You are given an n into n binary matrix grid. You are allowed to change at most 0 to 1. Okay, at most 1 0 to be 1. Return the size of the largest island in the grid after applying this operation. An island is four directionally connected group of ones. Okay, great. You have a grid 1 0 and 0 1. You have a grid C 1 0 0 1. Change 1 0 to 1 and connect two ones, then we get an island area of 3. Okay. Okay, change 1 0 to 1. Okay, now if I change any 0 to 1, it will connect the remaining island with the so it becomes a 3 size island, right? Right. Now grade 1 comma 1 comma 1 comma 0. Now change 1 to 0 and it becomes 4. Okay. Why this no activity here? There's no need of that. 1 1 0. We have 1 1 1 0. Change this 0 to 1 and it becomes a connected island of size 4. So what I need to do is I will need to do a BFS to find the size of island. That is a fixed thing. BFS or DFS would do the job to find the island size. And what I'm when you are given an n-cross and binary matrix, you are allowed to change at most 1 0 to 1. Return the size of the largest island in the grid after applying this operation. Okay, so let's just create a 3 cross 3 matrix. I have a 3 cross 3 matrix, and then let's create some case. We have 1 1 1 1, but it is 0 here, and it is 0 here, and this is 1 1. This shall also be a 0, then it should be good, and this is a 1. Now what I am planning to do is change, find the which 0 will work best, right? So let's just change. Uh, so let's why not just work in this particular matrix only? Let's just change this 0 to a 1. Now what is the size that I find is this is the size of the island. It is 1 2 3 4 5 6. 6 is one answer, right? Okay, sorry. 6 is one answer. Now let's just Change this to 0 again, it was 0. And now just change this to 1. Okay, even after doing so, what is the size that I found? The best is 3, 3 to 5, 5 plus 1, 6, 6, and this was changed. I think 7 was the best answer in the previous case, right? 3, 3, 6, 9. Okay, so 7 was the best answer in the previous case. I made a counting error. So 7 was the best answer. The previous case, second answer that I get is 6. Okay. Okay, let's change it to 0 back. And now let's change this 0 to 1. Now this is a 1, this is 3, 3, 6, 6, 1, 7. Okay, again I get 7. So out of these three, 7 is my best answer. So either I change this 0 to a 1, or I change this particular 0 to a 1, right? So what I can do is find every 0 in this matrix and change it to a 1, and then do a DFS traversal to find the size of the graph, right? And then what I can do next is revert that 0 back to, revert that 0 to its initial case, that was a 0, and that could be my answer, right? Okay, so let's try to code this thing. If I work with this particular logic, okay, making a large Iceland, we have an 500 comma 500, huh? Say 500 into 500, it's quite a big matrix if we go that way. Well, what can be done? Let's try to code this. We have int n is equal to grid dot size. Okay, then we have int m is equal to grid 0 dot size, finding the size of rows and columns. And then what I need to find is the max area, right? Area is 0 initially. For int I is equal to 0 dot I is less than int dot I plus plus, or int j is equal to 0, where 0 dot j is less than m dot j plus plus. Now what I need to do is, if grid I bracket j is equal to 0, then do one thing: change grid I bracket j to 1. Now I need to do a DFS, and from where I shall start my DFS. Every one node will be a valid node, right? So from every one node I will start a DFS, right? Okay, for int I is equal to 0 dot I is less than n dot I plus plus, or int j is equal to 0, j is less than m dot j plus plus. If grid I bracket j is equal to 1, then call the DFS, and I have to write a DFS for this particular thing. And what will the DFS be doing? DFS will get me an answer that I have to compare to find my best answer, right? Right. Okay, let's just make some equivalent amount of gapping. So it is to work around with this. Sorry, too much. Ch- DFS. What I need to pass in my DFS? I need to pass my. I have already ing, so it's better to avoid this. And let's just use x and y here. Y. Just remove this particular part completely. Now just change it to x now, right? Just change it to x. Sorry, this would be changed to y. Now if grid x bracket y is equal to 1, then call a DFS. DFS will send x comma y and my grid, and also I need to send a visited, right? Okay, I will send visited so that I don't visit each node again and again. Okay, that's good, that's good. So I have to also create the visited, right? I just create a simple visited to vector int, or shall we go with bool? Let's go with bool. Bool visited. uh, we have n, then we have comma vector bool bracket n comma false, initialized well and good. For comparison, I would need a large value, right? Largest is equal to 0. Initialize with 0. I will call it here every time. Find the best answer. Largest is equal to max of largest comma DFS. Okay. Now what I need to do next? Uh, I need to call a DFS first. Okay, it is a TFS that would be returning something to me. That is something. I have int x comma int y comma. I have a grade that is vector int grade grade, and as well as I have vector bool called visited. And then what I need to do is do a simple BFS. Uh, First thing first that I will do is visited x bracket y would be marked as true. Now what I need to do is count the number of valid cells, right? Initially the count would be set to 1, and I need to work in how many direction I can go in 4 direction, right? Let's create a vector. Vector vector int call it directions, then pass direction -1 comma 0, and similarly 0 comma -1 comma 1 comma 0, and then again a comma, and then 0 comma 1. Okay, good. What I need to do is index is equal to assign 1 count 1. Now I need to go in direction for auto diff that will go in directions, that is, and do one thing, that is get a new updated int x new x is equal to x plus direction 0 and new y is equal to y plus direction of 1. Okay, now again what will be happening is count plus is equal to DFS would be called, and for what we will be calling DFS is new x comma new y comma grade comma visited. Okay, and then I will return the count. This is my basic DFS. There's one thing missing, that is I'm not covered the case of going out of bound, right? There can be a case where I go out of bound, if x is equal less than 0, or somehow y is less than 0, or somehow x has become greater than equal to n, or somehow y has become greater than or equal to m. In that scenario, just return 0. Now this is such a long code to work with that someone like with me is about to make some great amount of errors. I found the best answer, right? Okay, I called it, I checked it, I found my best answer. Now what I shall be doing is be changing, right? Changing what? I shall change first thing first, that is grid. I chip that was changed to 0 from to 1 from 0 now shall be reverted back to 0 after the work has been over. Okay, and what next? And what next? We need to find the best answer, right? So max area would be max area comma comma largest, right? And then return the max area, right? Let's try to run this. If it's run in once, then it would be great. Compilation error, not past n and m, right? Okay, this grid dot size, whatever it may be, and here it will be grid 0 dot size. Let's try to run this now. Grid ij is equal to 1. Okay, I have written it's greedy. Okay, one more thing that I guess I'm missing is this or condition should be here. It is visited x comma y. If you have already visited, then just return 0 because I am not checking here, right? If I'm not making a check here, then I shall make a check here. Largest. Where's the largest? Spelling error here. Now let's see what happens. Okay, one case works. This case fails. Why? It is giving 4 when it shall be 3. Mhm. Let's see. I have passed my cell if it is converted to 1. If x is equal to 0, y is less than 0, x is greater than grade, y is greater than z, or has been visited. Or one more condition that was needed to be checked was it is grid x bracket y is a 0. If it is 0, then we can't traverse it, right? We have to go back. Okay, now one case fails, that is 0. Expected output 0, no, expected output 4, but I am giving 0. This in this particular case, int I is equal to 0, I and n, or j is equal to 0, j is less than n, vector int, great, So what is happening here is that because this is a condition that only works when I am having a zero in a grid, and in this grid since there is no zero, then I will never do a DFS, and since I will never do a DFS, I will never get the answer of the area, so that is why it is returning max area 0. I can write a simple ternary operator here saying that if max area, uh, wrap it in a bracket, if max area is equal to 0, then do one thing, that is return m cross n, else return max area. Let's try it. Okay, it's run well. Let's try to submit this. Okay, 52 out of 75, and we hit TLE, time limit exceeded. Well, we are having a large amount of size of grid, that is 1 to 500, so 500 into 500, you can guess. It is a quite a big grid answer. How I need to work on this particular question again to improve it. Well, the order of time complexity is already, if I see here, it is n cross n into n cross n into n cross n to power 4. Not even n square, I'm working on n to power 4, then it was supposed to happen. Because I'm already going beyond 500 into 500 into 500. 4 times, quite a big number. Gosh. Then I am supposed to improve this. Somehow, I need to do this traversal at any cost. If I can just take this loop outside, this is the loop that is causing the issue. This TFS for every cell that I'm doing. Not every cell, but there could be a case now where every cell of the matrix is 0. So then I would need to do this TFS from every cell. I could just take this TFS out. Okay, if I could just take this TFS out. Uh, just erase this. Try to draw the matrix. My hands are not. Have this matrix. The cells. This is one. 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 And this is 0. This is 0. And this is 0. What I need to do, what I do every time is I call a DFS from every 0 cell that I turn. Okay. I think of a DP solution here. If have a DP solution here, somehow I can store the solution in memory. But what I will store, every time I turn this cell to 1, it goes into a DFS around it 4 directions. Find the area from that 4 direction and then add 1 to it, right? But how come I can store this in my DP? I mean to say there's no
valid way to store this in a DP or something. And even why I would just put that random DP on this particular portion, because I need to eliminate these two loops. Somehow just I can know if I run RTFS previous to these changes, then what is the size of the Iceland? That is this, right? Now this Iceland uh, is adjacent to this node and this node. So only these two nodes can directly get attached to this Iceland, right? So this node will never get attached to this Iceland part. It would remain single here. But these two can get connected. If I already know this area, then I can just attach these two nodes and find the answer, right? But there could be a case of, let's just increase the size of matrix. Just a second. Just a second. Okay. If I increase the size of matrix like this, and then here also something like this, do the job. Okay, great. 10, 10, and 10. Now this is 1, this is 1, this is 1, this is 1. This is also 1. This is 1, this is 1, this is 1. But this is 0. And this is 1, this is 1. Okay. So similarly, there's a DFS that goes here and find this area. Now this is connected to this also. And it is connected to this also. Now this 0 which was not participating in this will be participating with this and will get connected to this Iceland from here, and then because this Iceland is connected here, okay, and then this and this, okay, so this will also become a part of pretty huge chunk, right? So it is not necessary that if it is not connecting with this, it might connect with this. uh, but that's the part right now. If I all know the four direction to which it is connected to a valid Iceland, and I already know this area, then I could just add it. I mean to say, what I need to do is add this area to this node. Now this area is this complete graph. That is a DFS thing. I have done a DFS. I know this size, but there could be a case that uh, somehow I need to break this chain, right? Somehow I need to break this chain. I need to break this chain. If I make a 0 here, okay, so let's just raise this little, okay, not too much. Okay, great. Now, if I change this particular node to 0, now when I turn this node to 1, it would be only connected to this. Great. Now I won't get answer in a single DFS. I need to do multiple DFS again for this, right? Because one DFS for this and one DFS for this graph, but still the concept remains that if I know this size, then I can just add one node to it, and if it was connected to some other graph on its left, but I know the size of that, I can add that too also. But how will I go from every edge?
and store a size. To say, even if I start a DFS from here, then I go here, then only my size will increase to 2. Then here go I 3. If I go here 4, then 5, then 6, then 7, then this node will know that the size is 8. Then I need to propagate this answer back also. As I move forward by increasing the size uh, continuously forward, then return that particular thing back also, right? Start a loop from that particular node, then go here until unless I can't go any further, and then I will return back what my max size was. But after this, there could be a case this all they are zero and this was only, and after this I can't go any further. So that is also a case. It would return zero. How come I supposed to find? How am I supposed to fill this size? Even if find this disk size 8 to all these elements in this particular traversal. I traverse a graph and to fill that, how? Uh, if I have a graph, this need to fill this particular size in this graph part only, then how come I do this? Um, I could store something in map. Somehow if I create a string of this, if I create a string of this, okay, 0, the, whatever the cell ij is here, and then whatever forward traversal I make, I create a string in that, then do that to that. But how will I know that this particular cell is a part of this string, right? Every time my string size would also increase, and it would not be feasible to store it in a string form. Okay, if can't stored in a string, if I could have stored in a string, then I could have a map where every string will know the size, right? But the issue is I will create a huge string, right? I will create a huge string, and this huge string, let's say XYZB, has size 8. But how come I will know that this particular cell was part of this string? Then I will need to map this again to this, right? If I could have if I could have this particular string pre-assigned, instead of creating a string made out of this cell, I made a string XYZB and filled this XYZB here, right? Now when I move to cell 2, I fill this again here, this again here, this again here, and so on until unless I can't move any further. I will fill XYZB in this. So this whole component, that was this component, would be X Y Z B. and I could just find the size of XYZB while naming it. So it would be a issue, and XYZB would have a size 8, right? And what I can do is, now since I have filled XYZB in this, I will go and now I will ask what is the next cell to you, and it will say it is XYZB, and XYZB I already know it is 8, so I will add 1 plus 8. I can do the same here, right? I can name it WTP, WTP, and I will know that this is WTP. So my answer would be WTP plus 1 plus, sorry, plus 1 plus XYZP. Now this is my answer to name them. So instead of using a string, I can replace this with an ID also, for a character. A, 1, 2, 3, any number would work, right? I just have to rename it to a number ID, because maintaining a string, it would be better to maintain a number ID or character ID, right? Okay, how would I code this? I will go and start a DFS from every non-visited one, and I will keep naming that according to my ID, whatever ID I've taken, and I will keep finding the size. After I completed one DFS, I will, in my map, I will store ID and the size, and increase the ID plus plus, and the size would be calculated again using a DFS. Now, what I need to do is, the next thing is that these all numbers would be changed to ID, right? So I have to make sure that when I do this, I will find the ID of upper, left, right, and lower, and just calculate the sum from the map, right? From map, I will find the upper ID size, lower ID size, left ID size, right ID size, and that sum plus 1 would be my answer for every zero, right? So if I work with this, the particular, this for loop that was inside this would now come out, and it would be turning from order of n to power 4 to order of m cross n, right? They are, okay, so n cross n, sorry, so order of n cross n. And I think order of n cross n is pretty good, considering it's a grid based question. So I think what I shall do is reset this code. Let's try our new approach. Gosh, I think it's a pretty long solution considering the case, right? Right. Let's get started. What I need is uh, size of the grid. Just take it outside globally, because it would be needed outside also, right? Int n and int m. Let's just make them outside global. And now, not making the same mistake again, in grid dot size, okay, and m is equal to grid 0 dot size. Now what I need to do is find the max area and the max area and a DFS, right? So I will have max area is equal to 0. That would be my initial max area. Now I need ID map, right? Unordered map. And let's just make it int based instead of character. Let's just make it int based unordered map MP, and then int ice ID is equal to, we have 0 and 1 initially, so we can start our ID as 2. And now for int I equal to 0, I less than n dot I plus plus. For int j is equal to 0 dot j is less than m dot j plus plus. And if create I bracket j is equal to 1, I would also check this state, right? I need to check this state. I can check this state in the upper part, right? And since I've already changed the ID, so I won't need to check the state anymore, I guess. Okay, now what I need is int size would be my DFS. I will get the DFS, will still return my size. So I comma j comma my grid would be send, and one more thing, that is ice ID. What I will do is now in my MP ice ID would hold the size, Okay, great. Now what I need is ice ID needs to be added forward. Now let's firstly write our DFS. Let's write int DFS of int I comma and j comma create, sorry, vector vector int at create int at the rate, sorry, and ice ID. Now do one thing, that is first let's check the conditions. If I is less than 0, or j is less than 0, or I is greater than equal to m, sorry, n, or j is greater than equal to m, or rate I bracket j is not equal to 1, then do one thing, that is uh, return 0, because I can't go any further, just return whatever the 0 size it is. Okay, now do one thing, that is create I bracket j is equal to ice ID. Assign the ID here. Now what I need to do is again create a vector directions. So vector int directions, and that would be starting -1 comma 0 comma 0 comma -1 comma 1 comma 0 comma 0 comma 1, right? Apart from this, now let's move forward, that is for auto dir that goes in directions, and that is int new x is equal to I plus direction of 0, and int new y would be j plus direction of 1, right? Now what will be happening is I need to do I need to add the size, right? Int count is equal to 1, that is initially. What will happen is count plus is equal to dfs new x comma new y comma grade comma is is id, right? And what will happen is I will return the count. Now what happened till here is ice id and all this part is done. What I need to do is to traverse the matrix for int I is equal to 0 dot I is less than n dot I plus plus, for int j is equal to 0 dot j is less than m dot j plus plus. If grade I bracket j is equal to 0, then what will happen is I have to get the 4 direction id. What would the 4 direction id? uh, Whatever it be, to get that id, and then from that id to get the size from map and add it to my answer, right? So I can store it in a set, ordered set, that will hold int called st for now, or sorry, auto diff, that will go in direction. Do one thing, that is int x is equal to I plus direction 0, and then y plus y is equal to j plus direction 1. Now what we will do is st dot insert grade x comma xy, right? And we need to check a condition also. If x is greater than equal to 0 and y is greater than equal to 0 and x is less than m n and y is less than m, right? And grade x bracket y is not equal to 0, then only do this. After doing so, you have inserted in the grid. What I need to do again is need to do another loop that would be on map, on the set, or auto s, that would go in st. I will do one thing, that is again create int count, that is 1, auto st is equal to count plus uh, mp bracket s, right? And mp bracket s, and now the max area is max area, sorry, max area is equal to max of max area comma count, right? And then finally I will return max area. So I guess it should work if there are no compilation and runtime errors that I encounter a lot. Okay, mpid where I have returned this, it is id. God see, yes, compilation and runtime errors and this case shall work. Another same error. Da, 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 da. Okay, I have made the same issue again, so I will just do it just like last time. I will wrap it inside my area equal to 0, then do one thing, that is m cross n is return max area, right? Compilation error. What is the compilation error? What is the compilation error? Uh, Synced. Okay, I guess this is the compilation error. Okay, it works so far. Let's see what happens. Okay, it has worked. So the time complexity that was originally order of n to the power 4 has reduced to order of n cross n. And we have successfully solved this particular problem also. How many summation it took? It took two summation. Okay, now one more problem into that is longest cycle in a graph, right? What we need to do is find the longest cycle in a graph. Okay, just a second. Need some water. Give me a 5 minute break. I'm coming back. Just 5 minutes. So I guess I was able to get back before 5 minutes. Right. So now move forward to this next problem. That is longest cycle in a graph. So I have worked on the cycle part of the graph in my first video, and I think this is a directed graph. So I've talked about the directed graph cycle detection technique there. Now let's see if we can relate this problem to that. You are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. Okay, the graph is represented with a given zero index array edges of size n, indicating that there is a directed edge from node I to from node I to edge I. If there is no outgoing edge from node I, then edge I is equal to minus 1. Okay, return the length of the longest cycle in the graph. If no cycle exists, return minus 1. Okay, so from node 0 there's goes h3, from node 1 also there's h23, and from node 2 there's an h24, from node 3 there's an h22, and from node 4 there's h23. Okay, and I have to detect the longest cycle, and if there's no cycle present I have to return minus 1. Okay, let's see what we have. Okay, we have 3, then we have 310. Okay, 3 1, then we have 0, and then we have 2 comma 4, 2. Okay, there's nh from 2 to, okay, where's the eraser? It would be much better if I erase this h. From 3 there's nh to 2, 2 to this to 4, and from 4 there is 1 h to 3. Okay, it looks like this. uh, Now what I need to do is find the longest cycle in this graph. Now, very first thing, if you don't know about cycle detection in graph, I would recommend that you watch my first video of the BFS and DFS. I made it just 2 days back, so you can check it out there. And now let's see what is the longest cycle in this particular graph. If I start from node 1, I can go to node 3. Is there any cycle in this particular thing? No, there's no cycle. Okay, great. From node 0, let's use a different color. From node 1, I can go to node 3. There's no cycle. From node 0, I can go to node 3. There's no cycle. From node 2, I can go to node 4. Right. From node 4, I can go to node 3. Right. From node 3, I can go to node 2. And there exists my cycle of length 3. And there could be multiple cycles, right? Let's just say this is one scenario. Let's add multiple edges to it. And we have let's say we have node 2, right? From node 2, I have a edge to node 5. From 5, I have a edge to node 6. From node 6, I have a edge to node 7. From 7, I go to 8. And from 8, I go back to 2, right? Now, one cycle that I found was of size 3. Now I can go for another cycle from node 2. That would be from 2, I go to 5. From 5, I go to 6. From 6, 7, then 7 to 8, 8 back to 2. So 1, 2, 3, 4, 5. Now I find a cycle of 5, right? So in this particular case, we will be using Batman, I mean to say DFS, because I would be working with all the particular paths. I need to check all the paths. That would be so DFS would be working best for this particular case. Now I can write a simple recursive code to find a cycle in a graph, right? And that is not the issue in this particular thing. We can find cycle, that is not thing. We don't have to return true or false in this. We have to find the length of the longest cycle. How we find the length of the longest cycle? Okay, if I give number to each of my edge, then it will be 1, then 2, then 3, and then 3 minus 1 is 3 minus 1 is 2, then 2 plus 1 is 3, right? Okay, now from 2 again, 1, 2, 3, 4, 5, 5, and in number 1, 2, 3, 4, 5. So here also I numbered 1, 2, 3, right? So it's a 3 length. But when I come back to 2, I return the length of the 3. Uh, okay, that is I return 3. Can just keep passing that and find the distance. Or there is one more concept of in time and out time. Now this concept is not something that is very much of known or taught. It is a basic technique, so people know it by default. I've solved a similar problem on Geeks for Geeks. In that case, I encountered this in time and out time thing. So, what will happen is when I come to node 2, right, the in time of node 2 is 0. Now, from when node 2 to I go to node 4, the node 4 have in time plus 1 of that node 2. So node 4 have in time of 1. From node 4, when I go to node 3 would have int time plus of plus 1 of node 4. So node 3 would have int time of uh, 2, right? And from node 3 again, where I will go, from node 3 I will again go to node 2, right? And what is the length of the cycle in this? 3. Okay. From node 3, when I will go again to node 2, then I will encounter a cycle. So I have the distance 3 from, I have the distance between these two where the cycle will occur. So 3, 2 minus 0 is 2, and plus 1 is 3, my answer, right? Now for better understanding, let's understand this particular case where I have this. When I have node 2, I have in time of 0. When I go to node 5, I have in time of 1. When I go to node 6, I have in time of 2. When 7, it is 3. When 8, it is 4. Now, after 8, I will go again to 2, then it is 4 minus 0, it is 4, and then plus 1, it is 5. My answer, right? So, this is my end time concept. There are certain cases. There's this problem geek for geek. We have to check if there are two nodes that exist on a same path or not. So in that problem, I use this end time concept, and I'm using the same concept here also. So sometimes you need to match, and most of the times you need to find the pattern. Not sometimes. Problem solving, if you solve quantitative programming, you have to find the patterns. You have to work well with the patterns. So you will be able to guess patterns if you solve more problems. So I'm using that in time problem pattern here. So let's just use that same code to solve this particular problem. Okay, so what will be happening is write a simple solution. So int n is equal to edges dot size, right? That's the first thing that we should be doing now, because we need to do many things. We have vector pool, that is in recursion. Now if you don't understand this particular part, then watch my first video. There you can learn about this particular thing that I am doing, why I'm using this vector bool visited in comma false. Okay, great. Now what I need to do is create another vector, that is vector int, that is int time, and I n comma 0. Okay, great. Now what I will do is, for int I is equal to 0 dot I is less than n dot I plus plus, I will do one thing. If not visited I, then do DFS. Uh, then do DFS. What will the DFS do? What will the DFS do? My DFS will take I node, the edges present, visited in recursion, and my in time. Okay, now I have void DFS, right? That is int I, comma, vector bool visited, comma, vector bool in recursion, and vector int sorry, distance, not time. Time. Right. Now I have a node that I have, so I will do one thing. Visit it of I would become true. Right. We set this node to true. In recursion of I would also be set to true. Right. Now what I need to do is find the edge that is connected to this, that is edges bracket I. Right. Now if p is not equal to -1, I mean to say it is a valid node and not visited v, and visited not visited so far, then do one thing, that is in time of b is equal to in time of I plus 1. Okay, great. Now do DFS again from v visited comma in recursion and in time. Right. Now there's another case, else. It is not else, it is else if, because if v is not equal to -1 and in recursion, I mean to say this node is visited and is also part of n recursion, v is true, then what will happen is I need a result, right? So let's create a result here. Uh, int result is equal to -1. So I need to find the max answer. I will find it like this. Now my result would be updated to max of result, comma, in time of my v. No, because in time of I rather than v. Because in time of I would be higher than the in time of v, or in time of v would be higher than I. Sorry, this is sometimes confusing. Let's just use absolute for confusion. In time of v plus 1. Now after this do one thing, that is in recursion my node I would be marked as false, and finally I will return result here. I guess this shall do the job. Let's try to run this and see what happens. Compilation error, undeclared identifier edges. But, I have sent edges, right? Yes, I have not sent edges here. I guess what it is, vector integers. Vector int edges. So here I also have to send edges. Now let's try to run this. Another fail case in recursion. Instead of in recursion, I have typed incursion. In recursion, I guess. Unknown network error. Please try by reloading the page. Compilation error again, where it is in time, not in TT time. Let's see. Okay, it runs well. Let's try to submit this. What happens? Let's see, let's see, let's see, let's see, let's see. Okay, it has submitted. It's a simple DFS code, and we know the complexity of DFS. It's sort of V plus E, so don't guess it is pretty tough to do. But this is a new concept that will come handy in some particular problems that you will solve in future. So yeah, this concept we did. Now, like to move forward to the next particular problem. Minimum time to collect, and it is one already. I started around uh, 11. So shall I go to these four problems more, or shall I stop today? The problems are remaining key rooms, minimum score of path between two cities, and maximize the number of target node. Uh, for today, I think this much is okay because I'm going to stop now. So thank you for watching, and from tomorrow I will complete Deshkastra, and these four remaining problems I will solve them definitely, but not today because it's already uh, more than one. So I think I need some rest also. Thank you for watching.